The story of programming languages begins not with computers, but with mathematicians. In the 19th century, Ada Lovelace, daughter of Lord Byron, imagined a future where machines could manipulate symbols according to rules. She wrote what is considered the first computer program, a set of instructions for Charles Babbage's analytical engine, a mechanical computer that was never built. The mid-20th century saw the emergence of the first electronic computers. These machines were behemoths understood only by a select few. Programmers communicated with them using machine code, a series of zeros and ones that directly controlled the computer's hardware. Writing machine code was tedious and error-prone, requiring an intimate knowledge of the specific computer's architecture. The need for a more human-friendly way to program computers quickly became apparent. In the 1950s, the first high-level programming languages were born. These languages allowed programmers to write instructions in a more abstract way, using English-like words and mathematical notation. This code would then be translated into machine code by a program called a compiler. One of the earliest examples was shortcode, developed by John Mauchly in 1949 for the BNAC computer. Though rudimentary, it marked a significant step towards making programming more accessible. These early languages paved the way for the explosion of programming languages that followed. The late 1950s saw the arrival of two languages that would shape the landscape of programming for decades to come. Fortran and COBOL, developed by John Backus at IBM. Fortran, short for Formula Translation, was designed specifically for scientific and engineering computations. Fortran introduced concepts like variables, loops, and conditional statements, which are still fundamental to programming today. Its ability to handle complex mathematical calculations made it an instant success in fields like physics, engineering, and weather forecasting. COBOL, or Common Business-Oriented Language, developed by Grace Hopper and her team, targeted the business world. COBOL's English-like syntax was designed to be readable and self-documenting, making it easier for businesses to manage their data processing needs. COBOL's focus on data processing and file management made it ideal for applications like payroll systems, inventory management, and banking software. Both Fortran and COBOL proved incredibly influential, demonstrating the power of specialized languages tailored to specific domains. They remain in use today, a testament to their enduring legacy and the continued importance of legacy systems in various industries. While Fortran and COBOL were groundbreaking, they also had their limitations. As programs grew larger and more complex, they became increasingly difficult to understand and maintain. This led to the rise of structured programming, a paradigm that emphasized code clarity and organization. ALGOL, or algorithmic language, developed in the late 1950s, was a key driver of this shift. ALGOL introduced concepts like block structures, where code could be grouped into logical units, and recursion, where a function could call itself. Although ALGOL itself wasn't as widely adopted as Fortran or COBOL, its influence on subsequent languages was profound. Its emphasis on structured programming laid the groundwork for languages like Pascal and C, which would further refine these concepts and make them more accessible. ALGOL's impact extended beyond its direct descendants. Its focus on clear, readable code and its innovative features helped shape the way programmers thought about designing and writing software. It marked a significant step towards making programming more disciplined and less error-prone. Developed in the early 1970s by Dennis Ritchie at Bell Labs, C emerged as a powerful and versatile language. Initially designed for system programming, particularly for the Unix operating system, C quickly gained popularity for its efficiency, portability, and low-level access to hardware. C's concise syntax and rich set of operators gave programmers fine-grained control over system resources. This made it ideal for writing operating systems, device drivers, and embedded systems. However, C's influence extended far beyond system programming. Its speed and portability made it attractive for application development, and it soon became a language of choice for creating everything from databases to video games. C's influence on the programming world is immeasurable. It spawned countless derivatives, including C++, Objective-C, and C#. each building on its strengths and adapting to new programming paradigms. Even today, C remains a widely used language, taught in computer science courses worldwide and employed in a vast array of applications. Its legacy is a testament to the power of elegant design and a focus on efficiency.